Last but not least, we have Vishakha from ApertureData, and I will introduce him shortly, but with years of research experience, Vishakha has led the building of a new type of database storage system that's really come to be important in the last couple of years. And ApertureData is a system that combines two of the most important search functionalities for generative AI, graphs and vector search. So today she's here to share more information about how this system is especially important in Gen AI use cases. So let me bring up Vishakha. Awesome.
Hi, Megan.
Hello. The best for last. So I will hand the stage over to you.
It's either best for last or it's like everyone is tuned out and I have a lot of work to do.
Definitely best for last.
All right. Hopefully everyone can hear me and see my slides. The best case, please keep it interactive. I can go deeper into any of the points that I make here. It'll be great if it's driven by your questions. So post your questions on YouTube or the Discord chats. Some of my teammates are online, and Eugene and Megan are here to pull those up too. Let's get started. So a few weeks back, when I presented during the LinkedIn Live session that Eugene does, I covered some use cases and examples around machine learning, large language models, retrieval augmented generation, and all the talks throughout the day today. They basically gave all the details there, so I don't really need to go there. But what I want to highlight there is how different modalities of data are so valuable everywhere, and that too in an exceedingly competitive and fast-paced AI market. I mean, think about it. If you did not do anything for 6 months, there'd be like 3 different versions of GPT by then. And all of this, I mean, if you go from the perspective of companies, they are doing all of this with the intention of driving up both operational efficiencies and customer growth. However, after conversations with hundreds of people on the ground across companies of various sizes and working on different use cases with different types of data, despite all these advances in AI and in all these models and techniques that we have heard all day today, the moment it comes back to actually deploying and getting these things to work in production, we keep hearing the same set of challenges. If they really want to get the most out of these AI techniques, the dream expectations or requirements from the data layer, because they need to incorporate their own data, sometimes fine-tune for end results, sometimes combine it in a way that gives them the results that actually match more of the human sort of expectations. And so what that invariably leads to is this set of requirements where could we have all our data be accessible from one backend instead of going to multiple different places? Could we search that data through multiple modalities? Could we make it easy maybe to do data set management? Because sometimes we have to create different versions of data sets. They come from different sources. There might be overlaps. How can we efficiently do this? Then, of course, if you're fine-tuning your models with certain data sets, you want to maintain a correlation. Maybe you had to modify the data along the way. How did it change? Who made that change? When you go in a production environment, that governance information becomes really important. And last but not the least, throughout this process, you want your data layer to keep working with all the machine learning tools that you already use or are planning to use. Now, these really, I call them dream set of requirements. Why? Because with data coming in from so many sources, it can also be very much scattered across various databases, cloud buckets, their local machines, which they write scripts and use processing libraries to bring that data together. So it's not really shocking when people lose track of what that data means, where it all lives, and how it impacts their searches and model development. In fact, it can get the real cost is the inefficiencies introduced when you try to tie multiple of these systems up together. And more than that, it's the lost opportunity cost. Like I was saying, if you took six months to put these pieces of data infrastructure together, and that's being optimistic, you've really missed certain generations of updates that happen to the models and techniques in that time. So what can we do about it? We solve this problem with a database. We are, my co-founder and I, very much systems and infrastructure people. We looked at machine learning as an application, and we thought, what can we do to make data and metadata access easy for every stage of machine learning and analytics pipeline? So we came up with this option of building a database that not only understood the complexity of multimodal data management, but also had this understanding of how this data was going to be used by AI teams. And so we could make it easy for them to adopt and deploy in production. And the result was ApertureDB. It's a purpose-built database for multimodal AI. And what do I mean by that? There are three important pieces, actually four. The first one, we natively built in support in our store and query APIs for the database to manage multimodal data like documents, audios, images, videos. We originally started out with computer vision data. So we have a lot more advanced interfaces to manage images and videos. So you can actually query ApertureDB to return videos, let's say at 1 frame per second, even if you had stored them at 30 frames per second. Or you can say, give me images in a resized and rotated format, and it'll do it on the fly. Then the next really important piece of this, especially as more and more people, especially as some of you have been improving RAG stacks, are realizing the value of metadata, particularly as entities and relationships between them. We analyzed a lot of applications when we were getting started, and the data model invariably matched with a graph database much better, with the graph data model much better. Which is why we started out with graph databases, and now it's actually, with all the work around knowledge graphs, it's a perfect fit because we manage application metadata in a memory optimized graph database so that it helps you build that knowledge graph as you capture the entities that are important in the documents or multimodal data that you're dealing with. And the relationships help you traverse complex relationships and find what you're looking for. And one of the aspects is because we were always thinking about machine learning and we started out with computer vision data, we also built in a lot of support for annotations. You have bounding boxes, video clips and frames, and you can do simple annotations on your on text information as well. Then another, and we've heard, and Eugene covered the whole vector database space here. Now embeddings since embeddings from PDFs, images, or videos make it possible to find similar things. So we also offer vector search and classification through our inbuilt vector database. You can index any dimensional feature vectors coming from any of your source data, and we'll help you search it. And I think when Eugene presented, he talked about how we blend the vector and graph together. It's because the vector embeddings in our database have a representation in the graph, which means they're connected to the rest of your application context. And it'll become clearer when I walk you through an example. Now, one of the important goals for us when we were building was to keep it simple for our users. These three systems sound like three completely different systems, kind of similar to what people have to do today. But then we have our, this query engine or orchestrator that we built on top of it, which essentially combines these things behind the scene. The users just query ApertureDB with a unified API, and internally we take care of redirecting the user queries to the right components and combining the results to give users a coherent response. And this is the interface at which the users of machine learning pipelines can interact with ApertureDB. So that's what we offer with Aperture. It offers a unified interface to store, search, and access all of users' documents, images, videos, application metadata, annotations, and embeddings. Now, of course, databases live together with other components in your pipeline. So as we saw earlier, ApertureDB can take care of managing metadata and data, and it horizontally scales. So you can scale, you can go to a pretty large scale that I'll cover later. We are also, ApertureDB is cloud agnostic. So it's possible to deploy it on any of your cloud providers or on-prem if needed. And ApertureDB we can basically store and access the data from the different cloud buckets or storage managed by the server itself. And of course, we provide a good set of client tools, primarily Python and C++ right now. And as our users require, we can introduce other client interfaces for ApertureDB. We have a good set of additional tools because, of course, you got to ingest the data, you need to query it. So we have parallel loaders. You essentially give it comma-separated value files, and we can ingest the data in parallel, and we'll take care of batching and pipelining it to the database. We also have different ways in which you can query the data that you ingest. We've recently been adding integrations to other frameworks like LangChain, but you can also directly do vector search, graph search, and get your data back from ApertureDB. We also end up working on the training and inference side with, with machine learning teams that are preparing the models. So we have integrations with tooling like PyTorch, TensorFlow to make that easier, and then Label Studio and labeling sort of tools like Label Studio. And then we have our own front end, so you can easily look at the data that you have. And of course, if you are thinking about, how would you scale this into production, how will you answer questions around data security and privacy, we already have built-in authentication, a role-based access control, logging and monitoring support when you deploy ApertureDB. Now, what sort of impact does it have when you make certain design choices, or you combine certain ways, or you acknowledge the way your data is going to be used? So now imagine if you could create your data sets 35 times faster. And this was an old paper with the older version of our database, and now it scales a lot more. So the numbers only get better, but they're not published outside. So I use the one that's published, and you can actually read about them. There was a result that at the beginning kind of surprised us, but then we realized, of course, it makes sense, is the reduction in network transfer. And you might wonder why, especially if you're thinking about image video type of data. Very often you reduce it in, you resize it down, or you're doing a thumbnail display of things, or you resize it for your model requirement. Because ApertureDB API allows you to apply those operations on the fly near the data, when you transfer this data, it's typically much smaller. 63% was one of the applications. For one of the other applications we measured, it was 6x savings because it was high resolution image, but they only cared about the regions of interest in that image, which is something we could give them through our interface. For vector databases, we have some numbers from our customer implementation, and we can be 2 to 4 times faster compared to some popular open source vector database. There's always, especially when you're thinking about multimodal data in production or deploying this on large scale, and how quickly can you do it? The biggest thing that appeals to our customers particularly is the fact that they can get started so much faster. And they can simplify their infrastructure so significantly. But not only that, we can actually scale to a fairly large data size, and we don't even know what the upper limit is because we keep testing up every time we get a new ceiling to achieve. So far, we know we can scale to over 1 billion entities in our graph, over 300 million images, and over millions of 4K dimension embeddings. So these are all well and good. It always helps to see something in action. So did we, by combining all these things and thinking so much about the API, did we really simplify the life of data scientists and engineers with our multimodal AI database? So let's see how maybe we could build a simple document search example. Before I do that, are there any questions? I'll keep going, and I'll just think Eugene will come online if he sees questions. So let's go see an example. Now, the first thing for any database is loading data into it. And I'll use a very simple toy example to show you how easy it is to build an application dealing with different data modalities in ApertureDB. Our client, you can very easily install it with pip. You can do pip install ApertureDB. Before I go into showing you a data loading example, I want to come back to the graph. Because for any application, the very first thing we do is understand the queries. We understand what are the data types on which we are going to run those queries. So here, what I want to build is take paragraphs from our documentation, extract embeddings from them, and then do a vector search. And so just for that part, let's say I want to create a schema in a graph. Now, a graph database, particularly the one we implement, it's a property graph model where you have nodes connected by edges. The nodes can be grouped together by tags or classes, and they have key value properties. You can have any number of key value properties in any number of nodes. You can introduce new key value properties whenever you want. That's the best part. It can evolve as your application grows. So you're not tied into a schema, which is very valuable, which was one of the big reasons why we chose a graph database model when we started. So here, for example, I made a schema, and this can be whatever your application requires. And if you were thinking from the perspective of, like, you've been in the SQL world, how does it map? In the SQL world, there would be a paragraphs table if you wanted to create this sort of a schema, and each row would represent a different paragraph. Here, each node represents a paragraph. You can have multiple paragraph nodes, and then they can have key value properties, for example, the actual text of the paragraph. Where does it start on the page? But I also wanted to connect it to the document where it came from. So I introduced a document entity or node in the graph, and I connect it with a paragraph. And I extract descriptor or embedding, and I used, like, let's say, descriptor set in ApertureDB is what we call a collection, is what I've heard some of the other terms. This is your search space for vector embeddings of the same dimension and extracted from the same model and representing the same search space. So let's say we want to create, we want to do vector search. So we create the collection, and we start adding descriptors per paragraph. Now, what I also want to do is, if there are any images connected to the paragraph, when I search for the right paragraph, I also want to see those images. So I introduce images in my property graph. Maybe later on I realize I want to track these images in a data set, because I'm going to query them by data sets and see what changed. Maybe because I want to train different models on the images that are there in my documentation, because they help me understand what's going on and if someone asks a question. So this is the toy example that we want to create, and this is how the graph can evolve. And the best part is it can be anything adapted to your application. So we have used the same sort of logic to work with an e-commerce vendor, with a retail vendor, with a biotech vendor. So we can apply it in different use case situation. Now, how do I create this graph? So let me take a toy example. So this is just our comma-separated value files. You can find them on our documentation, much easier to read them there. But I define my paragraph, and then I have certain properties about the paragraph. The same way, I have images that I'm going to ingest, and I'm going to connect those two together. So it's as simple as getting those CSV files and just running these commands, as you can see, ADB ingest from CSV, and then provide the ingestion type. So the first file is entities in the graph. The second one is a specially recognized entity in our database, because we recognize images. So you can do ingest type images with the CSV file. And then I connect those two. I define which paragraph connects to which image. The same way, I can ingest descriptors for the paragraphs, and they'll get connected to, after a few steps, they'll get connected to where they come from. In fact, it can be as easy as applying embedding a transformation on the fly on this command line, so you can ingest additional information alongside the data. But I won't go into it right now. Let's go see, once I ingested the data, can I actually go see it? So we have front end, which lets you look at the data. So what I did I have this metadata property on my images, and I did a search, and I wanted to see the properties. These are the images that I showed ingestion for. My database has other things which if I applied some other filters here, I would see images that match those filters. Another thing I want to show you from the dashboard is that you can see all the different objects and connections that are in the database. And as I mentioned, my demo database has all kinds of mixed data sets. So you'll see patients, you'll see products, you'll see cameras, all sorts of things. And you can see counts of how many of everything is present. This is a great way when you have separate data engineering or data science teams to look at the common view of their data. What is ingested? What are the property names? What are their types? Are they indexed or not? This is that one view where everyone can know what their ApertureDB data looks like. And of course, you can execute a similar thing on Jupyter notebooks as well. So that was just, we ingested the data, we were able to see it. If I go along the pipeline, we often get questions about integrations with, labeling or curation tools. While we can work with different tools, we can work with different curation tools like Visual Layer, the talk we heard earlier, or with labeling, we work with Label Studio right now. It's mainly driven by whatever our customers ask us to integrate with. But the more interesting aspect is querying the data. Most of the times, to answer questions. So if you are building an LLM and RAG stack for your application, for a chatbot, say, how would you query that data? So I showed you a toy example. Let's continue with that toy example. Now, here what I'm doing is essentially, I'm shifting now to the Jupyter notebook just to show the examples on how I can connect to the database, establish that everything is fine. So here I basically just connected to the database. This was the schema we discussed earlier on how to build it. I already ingested the data. So now if I ran with the search term, let's say Badger Technologies, I look for matching paragraphs. And what that code looks like, if I go into the helper function, it essentially is doing find descriptor is essentially find matching embedding. Embeddings are in our query API called descriptors. And you can say, this is the search space. I want 5 neighbors. And I want the connected entities with them. Now, this is where we are traversing the graph. And then you just return examples, which is where it shows you these were the 2 paragraphs that matched when you did a similarity search. Now, let's say I wanted to look at the connected images. If I look at the function, find connected images in the actual implementation, I again did a vector search. I found the paragraph, and then I went over to the images that we just connected through the CSV examples I showed. So it was a really easy way to show you how you were in the same database. You first did a vector search, and then you could actually use the graph to get to other data types. In this case, image. It could be a PDF. You could also apply additional filters that you only want images that are high resolution. The possibilities are enormous. Now, this is a toy example, but what we did was index Wikipedia data, which actually has 600. We took the 600 paragraph wiki data with Cohere embeddings that was already there on Hugging Face, and we indexed that. In fact, you can go on our website where you can go to the try free option, choose any of these, and the last one is the one I'm showing you right now, and run this yourself. This is our integration with LangChain to build a RAG, to show you a RAG and non-RAG example. So we build the chain for both. We use the ApertureDB vector store integration and the retrieval integration with LangChain. And what we do is we have some questions that you can ask this. So let's say I want to ask, you get a non-RAG answer, and you can get a RAG answer to it with references to the document. But we also tried to ask it questions around ApertureDB, but the model we used and the vectors that we had indexed, they didn't have really good answers to what we were looking for to answer questions about ApertureDB. So what we also did is crawl our own documentation and website. I think it's similar to the example, one of the examples we saw earlier. And we essentially here, if we come, I can ask questions around how do I store audio files in ApertureDB with our data now indexed, and you get a much better answer with pointers to the right documentation. In fact, that's really what we recently launched on our documentation. Go ahead and try it out and ask it questions. This chatbot is powered by ApertureDB Vector Search and by the example that you saw in that demo. Some of the other things that have come up is how do we deal with multimodal embeddings? So here, this example, essentially, we indexed clip embeddings. So we used the embeddings that come out of clip models that combine text and images. And when you give it a search term, pizza with friends, it goes and searches and finds images that correspond to that search term. And it was a very easy ingestion to just specify the COCO dataset images along with a clip embedding extractor together when we were loading on that ADB command line. And after that, you could just query using the multimodal embeddings. And where does the combination, how do we exploit the combination of graph and vectors? And this is yet another example of demo that you can use with celebrity faces. And here is where we not only find similar faces, but what we can restrict them is by metadata properties. You search with the set name, find similar images, and then restrict them by some metadata you care about. So I encourage you to go ahead and try these things, try these demos out. I can't cover a lot of things today, but hopefully that gives you an overview of all the different things you can do with Aperture. This is essentially like, we built some set of integrations to work in our customer pipeline. But the key part is if you choose the right database so that your data preparation time cuts down significantly, you really can shift your focus back to improving the models that you've been working on. I do get questions occasionally around, how do we compare with other vector databases, other graph databases, or just traditional databases. So we look at it as the right data layer for the overall pipeline, which means you want all these different properties that are not present in some of the other tools that we work with. So if you want something that unifies all the data and metadata access for the various stages of the work that you're doing, ApertureDB is built to support that. I am happy to answer any questions. We would love to hear from you. If you scan the barcode, or the QR code, it'll take you to all the relevant links. But the easiest, you can just write an email to us. And we're also on the Discord channel today. I will pause here now if there are any questions.
I did have one question for this specific talk that you just gave, which was, can you go back to your integrations slide?
One second.
How or why did you choose to do some of the integrations that you've done here? Why does it make sense to do BigQuery and Postgres and PyTorch and TensorFlow and Vertex?
As they're customer driven. That's the simplest answer. It's basically if they were migrating their data from some examples, what were they migrating from? And what were they going to use for querying, or what were they using as their labeling tool or their training frameworks? So it was where do we get the most ROI? The usual startup equation.
Okay, I see. Yes. Okay, that makes perfect sense. Okay, I didn't have any other questions pertaining to this specific slide or the specific presentation, but I did have a bunch of presentations before. We are over on time now. As there's no questions popping up in the chat, I think we can wrap this up.
Yeah, thanks a lot for inviting me. And it was a great learning experience today. Thank you, both of you.
Thank you, Vishakha.
Yes. Thank you for coming, Vishakha. Thanks for being such a great closer.
Tried.